Any answers? For each new axis, do I need a new definition, new formula? You are saying it is the same, right? Yes or no? It's the same. Why?
Doesn't need another formula to every axis.
Right, because if I change the axis, I call this x, this y, this z, but I haven't changed my vectors. V is still this, u is still this. Length of u is the same, length of v is the same, the angle between them is the same. Lengths of vectors and angles between vectors do not depend on which way you put your coordinates, clearly. Okay? So I derive this easy formula using an easy coordinate. Put one of my vectors along the x-axis and got the formula. What formula? U dot v, which is defined as ux vh plus uy vy plus uz vz, at the same time equals length of u times length of v times cosine of the angle between them. Now, that must be generally true, because the vectors as I have them are sitting there, the angle is the same. It doesn't matter how I read the coordinates. The coordinates themselves change, of course. The values ux equals 3, vy equals 5, whatever they are, if you change the axis, the numbers for the individual coordinates will change. But the result, which depends on the length of u, length of v, cosine of the angle between them, that doesn't change. Is this clear? So I have started with one definition of scalar product, which was just multiplying component by component. And then I have shown you that another formula is also useful, is true. So there are two different formulas for calculating scalar products. And of course they give the same numerical result. One of them is multiply the components, corresponding components, and add. And the other formula is just take the length, take the other length, and multiply those with the cosine of the angle between the two vectors. This will give you the same number, same result. Okay? Now, how did I get this formula? U dot v equals uv cos theta. Did I get it from experiment? This is a simple example of mathematical proof. It is not natural science, because I didn't do any experiment. I started with the definition and used some geometry and got a formula. I showed that if my original definition is the right definition, ux, vx, uy, vy, uz, vz, add, then it must also be true. If so, then this must also be true. Okay? This is proof. It is not science, it is mathematics. Okay, so we start with one definition, you get another definition. Clear? One thing that I forgot to mention, I gave you the definition of dot product, u dot v. Is u dot v the same as v dot u? With either of my formulas, either definition, if I change the order of ux, vx, u, v, everything, does it change? Does it matter? No, it doesn't. Good. So, just like ordinary multiplication, this multiplication is also commutative. It doesn't matter in what order you put the numbers in. Okay? Now let us do together one example. Now why am I introducing this concept? Because it's useful. Because it has applications that help us understand things and calculate things in science. Okay? also, of course, the first thing to do is if you introduce a definition of a mathematical operation, it must be a real mathematical operation. It must be consistent. The way you use it shouldn't lead to any mistakes, any inconsistencies. Okay, so it's mathematically consistent, which I'm not going to show, but this definition is a good kind of product definition as far as mathematics is concerned. And I want to use it as a scientist because there are certain quantities in science which need the dot product. My example will be from work. Now I'm going to use it as an example. Many of you don't know or don't remember what work is. Don't worry, we are not trying to understand what is work. I'm just going to use it as an example, as a formula. Okay? Later on we'll learn what it is and where it comes from. This little girl is pulling a sled, kızak, with a rope. Okay? Of course, she's applying a force to pull it. And as a result, this sled is moving, has moved through a distance d along the ground. F, the force, is a vector because it has a direction. And d is, of course, also a vector. And she's spending some energy doing this. This is what we call work. Okay? Again, you don't have to know what really work is. We'll learn it later. But there is some such thing that is work that's important. And she is doing work. And the definition of work is F dot d. Take the force as a vector. Take the distance as a vector. And take the scalar product. So let me give you some numbers so we can calculate it. Let's say F equals 3I plus J, just one J, let's say, and the unit is kilogram meter per second square. And let's say D is 10I, and the unit is meters. Okay? Now let me calculate Can somebody tell me what the work done is? What is it? 30. Okay. 30 and I. I is a vector. The scalar product is a number. It doesn't have any direction. Work, as we'll learn later, is also a scalar. It just means how much energy she's spending? Just 30. Okay? No I. And what's the unit? Kilogram, meter square, because there's a meter from each term, divided by second square. Is this clear? Now, let's do another. Let me ask you another thing. Remember, okay, I want to ask you, what is the magnitude of the force? Okay, I have learned that she is pulling this with a force of 30 in the x direction and, no, with a force of 3 in the x direction and 1 upward, so that she's pulling it this way. 3I plus j. Altogether, what is the magnitude of the force that is applied on this rope? Yeah, okay. Square root of 10. The square root of 3 square plus 1 square equals root 10. What's the unit? It's a force. Now, what is the angle between this rope? What is the angle between the rope and the ground? Well, the name is usually theta. If you want, I can call it beta, but okay. The name doesn't matter. What's the number? Okay, let's do that now. So this angle I call theta. So my question is, theta equals what?
3 divided by...
Right, 3 divided by square root of 10. Okay? So, how do I get that? Well, we know that F dot D, the work, is 30. I won't write units at this point, which we calculated using one definition. But the other definition is also valid. It must be equal to F, the magnitude of the force, D, the magnitude of the distance gone, times cos theta. So, cos theta is simply 30 divided by root 10 times, what's the length D? Times 10. Okay? So it's 3 over square root of 10. The cosine of this angle, I don't know what the angle is, but if I know its cosine, I can look it up from my calculator or somewhere, okay? So this is the way to find the cosine. Is this clear? Does anybody have a question? Okay, now we have a break. Please take out a piece of paper. If you have any questions that you don't understand, write it down. Let me remind you of the rule again. One person, one piece of paper. Hand it in personally, not for your friend, and go out.